So you are given two salts to analyze. What are the salts? We have one, we have lead 2 triosonitrate. We have lead 2 triosonitrate, and we have analyze for potassium ion. You are expected to analyze for what? SO2 gas, sorry, SO3, that is sulfide ion, and what? SO2 gas, sulfur dioxide. These are the things. Then the next thing is you are asked to find the oxidizing property of this sulfate or this sulfide. Do you understand? So oxidizing property of this one, which one of the reagents that are being given is K, potassium permanganate, and what? Potassium chromate, heptaoxochromate. These are the two, and these two things indicate the presence is an oxidizing property. This one, of course, will decode NO3. We are going to look at this one first. Now, the first thing you are going to do is that, for instance, this side will be given to you. All right, this side will be given. So you say, probably you say A. This is A. Now this one, then title it what? To be C. In what they have get to SO3 is titled what? D, which we are going to look at now. Now, what you are expected to do is that you add this one. You say C plus distilled water. Distilled water. Now, when you dissolve this thing in water, they can give you the meals, or I told you that this one might probably be report will be given to you. Now, what you are going to observe is what? C dissolve to form a clear, a colorless solution. C dissolve to form a colorless solution. Is that understood? So now, what you are expected to report in your inference, since C dissolve, you say that C is what? C is a soluble salt. C is what? A soluble salt. Now, you might be asked to test C with what? With litmus paper. You might be asked to test C plus what? With litmus paper. You now say plus litmus paper. If you test this, look at C turn blue, litmus paper red. C turn blue litmus paper what? Red. So you now in your column you say that C is acidic salt. Beautiful. We are done with. Put this one into 3 portions. So we say a first portion. You say first portion. That is first portion of what? C. First portion of C. That is first portion plus NaOH. That is aqueous what? Sodium hydroxide in drops. When you put it in drops, what do you see? Then in essence, what do you see? When you put this sodium hydroxide in this solution containing this lead, what you have to see is white chalky. Some will say white precipitate or white chalky, but it's not white gelatinous. All right, white chalky, or let's just say white precipitate. Now, if you say white precipitate, there are different things that illustrate that. We say white chalky precipitate form. Now, what you are going to see when you see substance like this is either lead ion or calcium ion present. Do you get that? Now this is in drops, then in excess. When you add this one in excess, what do you observe? Say precipitate, dissolve. Precipitate what? Dissolve. This precipitate dissolve, or you can say precipitate soluble. You can use either soluble or dissolve. Now when this precipitate soluble, you say lead ion is what? Present. Present. If the precipitate doesn't dissolve, it is calcium that is present. But this one, since it dissolve, it is what? Lead ion is. Let's go to the what? The second portion. This one we say AII. Now the second portion, now this second portion, you have to minimize. Second portion plus what? Plus aqueous ammonia, NH3 aqueous. In drops, now in aqueous ammonia is the same thing. So we have what? White precipitate. You can say white chalky precipitate. Do you get that? Or white precipitate, white precipitate form. White precipitate is what? Form. Now you white precipitate is form. That's in drops. Then in excess. Then in excess. In excess, you see, in essence each column always trace it. Now then in essence say precipitate insoluble. Precipitate is what? Insoluble. So when precipitate is insoluble, you say lead 2 ion present. Lead 2 ion is present. Is that understood? Now let's go to the last test of this lead. So what you are going to do is that third portion. Now after that you roll line, so third portion now say third portion plus what? Plus dilute HCl. Are you following? Dilute HCl plus what? Plus heat. When you put dilute HCl, what you have going to observe is white precipitate on heat, or you can say on warming. Look at after this one, heat plus cold. When you heat it, you remove it and allow it to cool. So what you are going to report is white precipitate dissolve on warming or on heat, or heat/heat, and reappear on cooling. Are you seeing? White precipitate dissolve on warming or heat and reappear on what? On cooling. So you say lead 2 ion confirm. This one you are confirming it. So confirm. This is a confirmatory test for what? For lead 2 ion. So at this junction we have come to the end of this the first salt here. I told you that this nitrate we might not we will not analyze it because of what? Because of the reagent given in the practical. The reagent to analyze this one is not there, so you might likely not be given. So this is what they are expected to what? To get in the first aspect of this practical. Is that understood? Okay. So the next salt we are remember you are giving two salt. The next one we are going to analyze is K2SO3. Now in this one now, the first thing for you to analyze for K2, this one is normally done through what? Flame test. So just say this is our A, this okay, this is our B, this is our B. You say that this one is sample C D. So you say D plus non-luminous. We say that non-luminous flame, non-luminous flame. So when you carry your do a spatula of it and put it in a flame, all right, put it in a fire. So what you are going to observe is that a lilac or lilac, what you are going to observe is a lilac colored flame produce. This is what? K2, K1, sorry, potassium is K ion confirmed. You are done with that one. I hope you are following. The next one is you are going to look for your sulfate. All right. So you now say D Bi D plus distilled water distill H2O. This one I told you they are going to give you produce for. So D plus, because of this one, because of the presence of potassium, it will dissolve. So you say D dissolve in water to form what? A clear solution. So in your inference you say D is a soluble salt. Now you'll be asked to use this solution. First position, let's just say this BII. First position now, plus what you are going to ask first is barium chloride. All right, equals barium chloride. When you add solution, any solution that contains sulfate or sulfide, what you are going to see is white precipitate. White precipitate form. White precipitate is what? Formed. All right. So since white precipitate is formed, what you are going to observe or your inference will be what ion behave have this white precipitate. We have a lot of ion that behave like that. So you say sulfate ion behave like that. We have SO3, which we are looking at, behave like that. We have S2 minus behave like that, and even carbonate are what? Present. All this one are what? Present. Is that understood? Now you'll be asked to add what? After adding your barium chloride, add what? Plus what? Plus dilute HCl. Plus dilute HCl. What will happen to the precipitate? You see, precipitate let me write short form. Precipitate dissolves, or some people can say precipitate are what? Precipitate soluble. Precipitate is what? Soluble. Okay, now you say this one is SO3, that is sulfide ion is what? Is present. So second portion, this is second portion. Second portion plus either KMnO4 or what? K2CRO what? CRO2O. What you are going to do is that for this one now, for this particular one, you say decolorize acidify KMnO4. Do you get that? For this one, if you are asked to test for this one now, if you are asked to put this one, this is what you are going to report. Decolorize acidify what? Potassium permanganate. Are you following? Then if you are asked to test, use this one now, you say turn acidify K2CrO2O7 green. This one, because of the oxidizing property of this one now, will turn this this one is orange in color. Okay, this one is orange in color, so we turn that orange color to what? To green. Are you following? Why this one now is potassium permanganate is purple in color, so it will decolorize that purple. Is oxidizing property. We have done oxidation in our videos. Okay, oxidation and reduction. So what you are going to do is that D is a reducing agent. All right, now what we are going to look at next is SO2 that SO2 from this SO3. That's for SO2. Now the test for SO2, you say that third portion, this is second portion, third portion plus what? Plus, for you to hasten the, you can say dilute acid. They might give you dilute acid. This one, remember, this test now might be given to you. You might say dilute acid or what? Concentrated what? H2SO4. Let's just say plus concentrated H2SO what? 4 plus what? Plus heat, plus boiling, or you heat it. Now what you are going to observe is a colorless gas with a choking smell evolved. Do you get that? When you pass this solution now in acidify potassium permanganate, you say evolve, decolorize. The next thing is decolorize purple color of K potassium permanganate, or turn orange color of what? K2CR2O7 green. So when you pass this gas into this potassium permanganate and this potassium dichromate, heptaosochromate, and potassium permanganate, this is what you are going to observe. So this is what? Gas is SO2 from SO3 ion. So that is what that we have come to the end of our what our practical. So what you are going to do is that please like, comment, share, and also don't forget to subscribe to my YouTube.